Section 3.2, we're going to look at distance, midpoint, and circle. So let's start off with the idea behind distance. So the idea is you got 2 points. So let's say I got a point here. Let's call it P1. And let's give it some coordinates. Let's say you have x1 is your x coordinate, y1 is your y coordinate. And then you got another point up here. Let's call this one P2. P2 for point 2. We're going to give the coordinates x2, y2. Get really creative, right? And what we're going to do, we're going to connect those with a line segment. And the question is, how much distance is there between those two points? How many units of distance are there between those 2 points? So down here at the bottom, I'm going to create my x-axis. And here on the right side, I'm going to create my y-axis, my vertical, well, let's say horizontal and vertical axis. And I'm going to trace this to the y-axis, and this to the y-axis, and this to the x-axis, and this to the x-axis. And you get like a little triangle there. Now, the question is, what is the x value for P1? Well, the x value is going to be here x1, right? And what's the x value here going to be for P2? It's going to be x2. And for P1, what's the y value back here? This y value back here is going to be y1, right? And what's the y value for P2 back here is going to be y2. All right. Now, we're interested in something called distance. I'm going to make this red right here. The distance, d. We don't know it, right? Trying to find that. So what I'm going to do, I'm going to figure out, okay, what's first of all, the distance between x1 and x2, the distance between x1 and x2. So if let's say I had a number line here, I had a number 1 and a number 4. The distance there would be 3, right? 3 would be the distance. On a flat number line, you take 4 minus 1 to get 3. So the distance between x1 and x2, you take the larger number minus the smaller number. So you take x2 minus x1. All right. So now we're going to ask the question, what's the distance from y1 to y2? So from here to here. Well, you take the larger number, y2, minus the smaller number, y1. y2 minus y1. Yeah, so if I were to have a little triangle here, this were D, this side were A, let's say, and this side were B, and you have like a 90-degree corner here. That's called a right triangle. There's a special relationship between these 3 sides, and it's called the Pythagorean Theorem, gives us this result, Pythagorean Theorem. This is a result from basic geometry, Pythagorean Theorem. I don't know when you take geometry, 10th grade, 11th grade, and it goes something like this. A squared, so one leg squared, plus B squared, the other leg squared, equals the hypotenuse squared. And usually, when you're doing geometry, you call hypotenuse C, but we're going to call it D. D because it was our distance, D squared. So if we apply this formula to our triangle above, in place of the A, I'm going to put x2 minus x1. So I'm going to have x2 minus x1 squared plus, in place of the B, I'm going to put what? y2 minus y1 and square that. And then in place of the D, I'm just going to leave it D, right? We don't know what D is, so D squared. Now, I don't want D squared, I want just D by itself, right? So if we were solving this is a power equation, right? We have D to a power equals something. D to a power equals something. So what we would do, if you remember solving power equations, in the last chapter, chapter 2. We would drop the power, we would drop that square, and we put plus minus the square root. You have to put plus minus initially, because it's an even power. So you got x2 minus x1 squared under the radical plus y2 minus y1 squared under the radical. But then you think to yourself, remember, distances are never negative. It doesn't make any sense to have a negative distance. So in actuality, you're just going to remove the negative possibility. So you're just going to have a positive square root. So just only one root. You're not going to have a positive root and a negative root, just one root here. So that's going to be your distance formula. So I'm going to write that down formally. This is the distance formula. Let me write that down nicely. How do we state that? The distance between the points P1, X1, Y1, and P2, which is X2, Y2. So the distance between those 2 points is given by the formula, this formula, D equals the square root of parentheses x2 minus x1 quantity squared plus y2 minus y1 quantity squared, and keep that radical over the entire set of squares added together. Okay, so here's your formula. So you got to remember this formula right here. All right, so be aware of this formula. It's something you might just want to remember. All right, so we also want to look at the idea of what is the midpoint. So we got the distance formula. Now we want to look at a midpoint. So let's go back. Let's say I got P1 is x1, y1, and P2 is another point, x2, y2. And let's say we join these together. And this time we're not interested in the distance between those points. We're interested in a special point right here. What is that point is the question. Well, that's the halfway mark. It's called the midpoint. So we're interested in coming up with the formula. For that midpoint. I'm calling it MP for midpoint. All right, so what we're going to do almost the same thing we did last time. We're going to put down here a horizontal axis, and here on the side a vertical axis. We're going to trace this down here, We're going to call this x value x1. We're going to call this x value here x2. Okay, we're going to trace this back to the y-axis and this back to the y-axis. This y value down here we're going to call y1, and this one we're going to call y2. All right, now it gets interesting. We want to trace, so we'll take the midpoint, the red point there in the middle, and trace that down to the x-axis. And you ask the question, okay, what is the x value there? What is the x value there? So the x value, which is halfway in between x1 and x2, well, it's the average of x1 and x2, right? You average x1 and x2 together. You go x1 plus x2 divided by 2. So that's halfway in between x1 and x2. All right, and then you go back to your midpoint again, the red point, and you trace it back to the y-axis. And you ask, hey, what number is halfway between y1 and y2? Well, the average of y1 and y2, which is y1 plus y2 divided by 2. So you put those together and you get your formula for the midpoint. So your x coordinate is going to be x1 plus x2 divided by 2, comma, then your y coordinate, y1 plus y2 divided by 2. So literally, the midpoint formula it's a point, so it has two coordinates. The x-coordinate is the average of the x's, and the y-coordinate is the average of the y's. So let's write that down formally. Statement, the midpoint of the line segment joining the points P1, which is x1, y1, and P2, which is x2, y2. So the midpoint of the line segment, okay, we want to write this out nice. The midpoint of the line segment joining those 2 points, x1, y1, and x2, y2, is given by the formula, MP for midpoint equals, parentheses, x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So there you have it. There's your midpoint formula. Well, I should have used a different color maybe. Red? All right. So let's see if we can use these two formulas, the distance formula and the midpoint formulas, to do some just finding distance and midpoints.